All right, so the next thing we're moving on to, after reviewing the quadratic polynomial, we're going to move on to cubic equations. Now, a cubic equation with real coefficients has three roots that are classified as I. All three roots are real. All three are real, or one is real and two are imaginary. Or one is real or two are imaginary. So remember, the roots of a polynomial are the values of x for which the polynomial is equal to 0. So if you have a cubic polynomial that looks like this, and let us say this is x-axis and this is y-axis, this one would have three roots, three real roots, because it cuts the x-axis 3 times. Now, if your polynomial looks like this, it would have what? And let us say y-axis like that. It would have one real root and the other two roots would be imaginary. All right, so a graph of the polynomial, if it has three roots, means that the graph of the polynomial, the cubic polynomial, would cut the x-axis 3 times. The roots are the x-intercept. If it has one real root, it's because the graph only cuts the x-axis 1 time. All right, this is something that we will see later on. Not necessarily in this topic. So let us now say that if alpha, beta, and gamma are the roots of ax cubed plus bx plus c plus ax cubed plus bx squared plus cx plus d, then x cubed minus the sum of the roots, alpha plus beta plus gamma, x squared plus alpha gamma, beta gamma, x minus alpha beta gamma would be equal to, so in other words, if I multiply the three linear factors, if I multiply, let us say, x minus alpha by x minus beta by x minus gamma, if I multiply these three, I'm going to get this. Now, note the x cubed coefficient is 1. Now, since this would be equal to ax squared, ax cubed plus bx squared plus cx plus d, the first thing I'd have to do is divide the entire equation by a so as to make the x cubed coefficient on the left side and on the right side both be 1. So based on this, we can say that if the roots of a cubic equation are known, the equation is, so I actually said that 2 times unknowingly. The equation is x cubed, and you can see that here. The equation is x cubed minus the sum of the roots x squared plus the product of the roots 2 at a time x minus the product of the roots is equal to 0. So it's x cubed minus the sum of the roots x squared plus the product of the roots 2 at a time x minus the product of the roots is equal to 0. Now, what does that mean? This means if we equate coefficients, we can see that the sum of the roots would be equal to b minus b over a, where b is the x squared coefficient and a is the x cubed coefficient. The product of the roots 2 at a time would be equal to c over a, where c is the x coefficient and a is the x cubed coefficient. And the product of the roots would be equal to minus d over a, where d is the constant and a is the x cubed coefficient. All right, the following notations are important. So the sum of the roots, alpha plus beta plus gamma, can be written as sigma alpha. So if you see sigma alpha, it actually means alpha plus beta plus gamma. Now, the product of the roots two at a time, alpha beta, beta gamma plus alpha gamma, can be written as sigma alpha beta. So sigma alpha beta is the sum of the roots two at a time. The sum of the square of the roots can be written as sigma alpha squared, and the sum of the cubic of the roots could be written as sigma alpha cube. Now, sigma alpha square, which is the same as saying alpha square plus beta square equals gamma square, is equal to sigma alpha all square minus 2 sigma alpha beta. In other words, alpha square plus beta square plus gamma square is equal to alpha beta gamma all squared minus 2 alpha beta beta gamma alpha gamma. Sigma 1 over alpha is the same as saying 1 over alpha plus 1 over beta plus 1 over gamma. Sigma 1 over alpha square is 1 over alpha square plus 1 over beta square plus 1 over gamma square. And lastly, sigma alpha cube, which is the same as saying alpha cube plus beta cube plus gamma cube, is equal to sigma alpha all cube minus 3 sigma alpha times sigma alpha beta plus 3 sigma alpha beta gamma. In other words, alpha cube plus beta cube plus gamma cube is equal to alpha plus beta plus gamma cube minus 3 alpha plus beta plus gamma multiplied by alpha beta gamma plus 3 alpha beta gamma. With that in mind, please have a go at example 2. Now, example 2 says, given that 4x cubed minus 3x squared plus 2x plus 1 is equal to 0 has roots alpha, beta, gamma, where to find the sum of the roots, alpha plus beta plus gamma, the product of the roots two at a time, alpha beta, beta gamma plus gamma alpha, and the product of the roots, alpha beta gamma. Now, here's what we went through earlier. Earlier, we said that if the roots of a cubic equation are known, so the roots are known to be alpha, x is equal to what? Beta, and x is equal to gamma. If the roots are known, the equation with an x squared coefficient of 1 is going to be x cubed minus the sum of the roots, alpha plus beta plus gamma, x squared plus the product of the roots two at a time, alpha beta plus beta gamma plus alpha gamma, x minus the product of the roots, which would be what? Alpha, beta, gamma, and this would be equal to x cubed minus 3 over 4x squared plus 2 over 4 x plus 1 over 4, and this will be equal to 0. So all I did with 4x cubed minus 3x squared plus 2x plus 1 was to divide the entire equation by 4. So now, once both are in the same form or format, I can say that minus alpha plus beta plus gamma, the x squared coefficient on the left, is equal to minus 3/4 the x squared coefficient on the right. And so alpha plus beta plus gamma is equal to 3/4. You could say we multiply both sides by -1. Now, the product of the roots two at a time, alpha beta plus beta gamma plus alpha gamma, which is the x coefficient on the left, is equal to 2 over 4, the x coefficient on the right, which is the same as saying a half. And finally, minus alpha beta gamma, which is the constant on the left, is equal to 1/4, which is the constant on the right. Multiply both sides by -1, we get alpha beta gamma is equal to -1/4.